Hello and welcome to the chemistry guide. Today we are going to explain changes of state in terms of kinetic particle theory, including the interpretation of heating and cooling curve. The core idea of the kinetic theory is that all substances are made of very small particles, and this is used to explain the structure of the three different states of matter. As you can see, solid, liquid, and gas. The kinetic theory of matter describes these three states of matter and the change between them in terms of their movement of particles. As you can see, solid, check here, solid just vibrate about fixed breaths. Liquid, particles slide past each other. And gas, particles move randomly and rapidly. The main points of the kinetic theory: all matter is made up of very small particles, tiny particles, and different substances contain different types of particles, maybe atom, maybe molecule, and so on. The particles are moving all the time, and movement and arrangement of particles is different. As you can see, movement of solid, movement of liquid, and movement of gas. Remember, kinetic means movement. Still talking about the main points of the kinetic theory, an important aspect of this theory is energy. All particles have energy. The higher the temperature, the faster they move. This part will help you to explain different questions related to movement of particles, which increase or be faster by heat. In a gas, relatively large distance between particles, they are free to move anywhere, so a gas can fill any volume. Remember that increasing the energy in this direction, so gas has higher energy than liquid, and liquid has higher energy than solid, and the reverse, decreasing energy in this direction. Also, you have to know that pressure of gas is produced by atoms of molecules of gas hitting the walls of container. Check this one. Particles hit the walls of container. Particles hit the walls of container. The more often the particles collide with the walls, the greater the pressure. So you can see that increasing temperature, particles move faster, hit the container more often. This means higher pressure. Another key concept is intermolecular space, which refers to the space between the particles of matter. So there are spaces between particles of matter called intermolecular space. In gas, the intermolecular space is large and can be reduced by increasing external pressure. So we can say that gases are compressible. Most compressible form of matter, gases. While in liquid, this space is very much smaller, so liquids are not very compressible. Liquids not easily compressed. Solid, liquid, and gas. Applying the kinetic theory to change in physical state. Look at this figure. You can see solid. In solid, the particles are baked close together in regular arrangement or even lattice, not able to move freely, but just vibrate in their fixed place. When the temperature is raised, you just heat solid, the particles gain energy and vibrate more strongly. The particles occupy more space. This causes the solid to expand. Eventually, particles have enough energy to break the forces holding the lattice together and can move around. So we can say that solid melts melting takes place. In case of liquid, the particles closely bake together but in irregular arrangement. Regular arrangement, irregular arrangement. In case of liquid, particles are able to move around past each other. Remember, particles move past each other, keyword for liquid. What happens if we heat liquid? On heating, the particles move faster and the liquid expands. In the liquid, some particles have enough energy to escape from the surface. Remember, we talked before about evaporation. We mentioned that evaporation is considered as a surface process. So particles on the surface could escape. So evaporation takes place. Remember that evaporation can take place in any temperature. And as the temperature rises, more particles have enough energy to escape. So we can mention that evaporation is faster at higher temperature. Evaporation is faster at higher temperature. Once you reach to boiling point, the particles have enough energy to break the forces, attracting forces between them. So the particles move very fast and separate from each other, and we can say the liquid boils. So we are talking about two processes, evaporation and boiling. Evaporation occurs at any temperature, boiling occurs at specific temperature in case of pure substance. When we talk about gases, the gas particles are arranged totally irregular, spread very far apart, not close to each other like this one, compared to solid and liquid, and able to move randomly. Let's look at how the temperature changes during these processes. The energy change taking place during heating and cooling. On a heating curve, the temperature rises with heating in regions where single state is present, like this one. Check solid temperature rise, liquid temperature rise, and for gas temperature rise. So we can say that temperature rises with heating in regions where a single state is present. The energy of particles increases and they vibrate, move faster in case of solid. However, during a phase change like this one, melting or even boiling, the temperature stays constant. Even though energy is being added, this energy is used to overcome the forces holding the particles together, not to increase their speed, and this part including equation. Temperature remains constant during physical change of state. The temperature stays constant even though the energy is being added. This energy is used to overcome the forces holding particles together, not to increase their speed. When we talk about melting, the temperature stays constant, the energy brought in is used to overcome the forces holding the lattice together. And also when we talk about boiling, the temperature stays constant, the energy brought in makes the particles move faster and overcome the forces holding the liquid together. Then it converted into gas. In regions A, B, and C, the temperature rises with heating, the energy of particles increases, and they vibrate or move faster. In region B, the rate of evaporation increases with temperature. Reversing the experiment gives a cooling curve, like this one. The temperature stays constant during condensation, and gas and liquid phases both present in this case. So the temperature stays constant during condensation and also during freezing, and in this line, liquid and solid both present. Energy is given out in case of condensation and also in case of freezing. Condensation and the freezing considered as exothermic processes, while melting, evaporation, and boiling considered as endothermic processes. So the reverse is true for cooling curve, and during condensation and freezing, the temperature also stays constant, but the energy is given out. This means exothermic process. Thank you for joining me for this lesson on the kinetic theory of matter. See you next time. Don't forget to press the subscribe button to get more videos. Goodbye.